Hi, my name's Thomas Hurt. I'm an undergraduate TA here at UK with the FYE department. And today I'm basically just going to be talking about why I designed the peristaltic pump the way I designed it and kind of the engineering aspects that went into it. So basically, last semester, me and Dr. Whitney were talking, and she wanted to redesign the pump for the hydroponics project, and she wanted to do a peristaltic pump. And so I'm real into CAD and designing things, and I've got my own 3D printer, and so I kind of offered to help her with it. And so initially we and so pretty much like all peristaltic pumps kind of have a similar-ish design to this. Like there's a little ring, and then you've kind of got a little triangle piece with bearings that will squeeze a tube and push the water through. Some of them, there'll just be 2 of these, or some of them have 4, and some have an open face like this, and some have a closed face. But this is pretty much the most like generic design for a peristaltic pump. So initially, and neither one of us have designed a peristaltic pump before, so we, didn't, all we really knew was what they look like. So at first we thought maybe we could use one of these little DC motors. I think they still are included in y'all's Arduino kits. But so initially I designed something that looked pretty similar to this, but just with a hole in the middle for this DC motor. And that we pretty quickly found out that won't make nearly enough torque to actually do anything. It spins really fast, but it won't pump water at all. And then so we said okay, and we decided to try to use I don't know if you can see it, a continuous servo, which is basically the same thing that you get in your kits, but it's continuous. It can turn 360 degrees and keep going forever. And so I changed the design, basically the same thing, but with a insert in the middle for the servo to go, and it just connected straight to this little triangle piece with the bearings, and that kind of worked, but it didn't, like, it would pump water for 30 seconds and then the motor would overheat and it wouldn't move any water. And we didn't really want to have to get a different kind of motor like specifically for this project, so we had to figure out how we would make it work with what we had. And so basically I had the idea to use gears, because you can significantly increase the torque of a motor at the cost of speed. But I ended up doing that, and that worked really good. And that was the kind of the initial working design that I had for the peristaltic. And then we ended up going with this design for a while, and then after doing like a lot of testing and everything, we eventually would have problems. Like if the motor was running for 5-10 minutes at a time, it would start to overheat, and we would still have problems with it making enough torque. And so this right here is a 2-to-1 gear ratio, meaning that this little gear has to turn 2 full rotations to turn this big gear, which does increase the torque a lot, but it also slows the motor down. And even still, with the increase in torque, it would cause the motor to overheat after a while. So eventually we decided to kind of play around with the gear ratios and see if we could get something that was a little bit better torque wise, but without losing too much speed, because you don't want to have to wait 5 minutes for your reservoir in your hydroponic system to fill up. So here in the next clip, I'll show you a little comparison of the different gear ratios. So here's a comparison of the different gear ratios that we tried. This one's the original design, the 2-to-1 gear ratio, and I just said, sorry, my handwriting's pretty bad, but I said it's got decent torque and decent speed, and you can see I've got a little marker right here to show how many times it has to rotate. So there's 14 teeth on this one and 28 on this one, on this big one. And so if you divide 14 into 28, you get a 2-to-1 ratio, which means it has to rotate 2 full times to get around the gear. So you can see I'm rotating around, and now this one's about halfway around the gear, and it's rotated once, and then keep rotating it, and now it's gone around twice, and that's how you get the 2-to-1 gear ratio. And then we tried a 3-to-1 gear ratio, which same kind of thing. There's 10 teeth on this one and 30 teeth on this one. 10 or 30 divided by 10 is 3, so you have a 3-to-1 gear ratio, and you're going to get more torque but less speed. So you can see with this one, it's rotated once, and so now it's about a third of the way around. Now it's rotated twice, it's about 2/3 of the way around. And now it's rotated 3 times. So that's how you get the 3-to-1 gear ratio. And then we've got this one, which is a 4-to-1. So you've got the highest possible torque, but the slowest speed, because this one's going to have to rotate 4 times for this big gear to make a full revolution. So you can see it's rotated once, and now it's a fourth of the way around. Now it's rotated twice, and it's halfway around. And now it's rotated 3 times, and it's about 3/4 of the way around. And now it's done 4 turns, and it's back around to where it started. So basically, after a little bit of testing, and I'll kind of show a little demo of that in the next clip, we found that the 3-to-1 was probably the most optimal gear ratio, just because you're kind of getting more torque than the 2-to-1, but not as much as the 4-to-1. But the 4-to-1 it's going to take a lot longer to move the same amount of water, and so I'll kind of demonstrate that in the next clip, and so you can get an idea like how that will work with your project and in the real world. So I've got a little demo set up here just to kind of show you all the real world advantages and disadvantages of each of the gear ratios. So I've got a cup of water, and then right now I've got the Peristaltic set up with the 2-to-1 gear ratio, which was the original design. And I've got, basically I'm just going to start a stopwatch so you can see how long it's going to take this pump to pump a full cup of water. And then I've got this little laser thermometer to show you how much the motor is going to heat up. And you should see with the 2-to-1 gear ratio that the due to the limitations of torque, it's going to heat up more than the other ones will. And then with each test, I'll switch out the motor just to make sure it's fair. But you should definitely see that this one will heat up the most out of all the different gear ratios. So before I start, I'll show you the temperature. It's about 78 degrees, roughly. And then I'll, for the video, I'll do a time lapse so you don't have to sit here and watch the whole thing. So after the first test, it took 2 minutes and 20 seconds, and you can see the motor heated up. If I can get it in the right spot, it hit almost 90 degrees. Well, I can't get it, but see now it's at 82. So it did heat up a little bit. So now I've got the same test set up, but just with the 3-to-1 gear ratio. And I'll show you the temperature. It's about 77 degrees, same as last time. Okay. So you can see the 3-to-1 did take a little bit longer, but the pump speed was a lot more consistent. And let's see the temperature. So it's at about 84 degrees, roughly, or no, 88. So I think the highest, or no, it hit 92 actually. So actually not too much of a change in temperature. But still, it's, over time it will, like if you're running the pump for 5 or 6 minutes at a time, the 3-to-1 and the 4-to-1 gear ratio will heat up a lot less than the 2-to-1, just because the motor doesn't need to produce as much torque to actually rotate this. Now we've got the 4-to-1 gear ratio, and we'll check the temperature. It's about 77 degrees, so same as the other ones. Okay. So for the 4-to-1, you can see that it did take the longest time, and the pump was definitely the slowest, but it did not slow down at all. And let's see. It's a little cooler than it was with the other two tests. Well, it hit 90, but I think the last two hit 92, so still a little cooler, and it will definitely go a lot longer than it would with the 2-to-1 or the 3-to-1. It's just going to be a lot slower because this wheel will have to turn 4 times, or this one will, the small gear will turn 4 times for this to rotate once. So that's why it's going to be a lot slower.